Hello. Today I'm going to talk about significant figures. This is a key and fundamental concept in the world of chemistry. Okay, so let's talk accuracy versus precision. Accuracy is how close you are to the accepted value, while precision is the closeness of multiple measurements. So in a sense, for accuracy is how close you are to the answer. So when you're accurate, you're close to the answer. When you're precise, that means multiple answers are within the same boundaries. So they're not the actual answer, but they are close enough to each other that they are precise. So in a sense, you're getting the same answer every time, but it may not necessarily be the correct answer. So why do we use significant figures? All instruments of measurements have some sort of error. Tools have limits to them, such as a ruler has markings on it. But what happens if a measurement is in between those markings? Then you're off depending on how much you round by the measurement. So whenever you round, that specifies that a measurement is not exact. So that is the reason why we use significant figures, to show how much of an error we have within our measurements that we take in chemistry. So how do we view these errors? So think about a pen that's about 10.23 centimeters. So a 10.23 measurement would be somewhere around there. So the exact values that we are accurate about is 10.2, so we are sure that it's more than 10.2. However, the 0.3 is an estimate of the measurement in between the lines, because it's past the marking of the ruler, but it's not close enough to the next marking to be an exact answer. So the precision of the measurement is to the nearest 0.1 centimeter, whether that be adding or subtracting, so plus or minus 0.01. This is the same with graduated cylinders and all other instruments. So the rules. The last digit in any measurement is a guess. So as we saw with the ruler, the final digit was the one that was measured in between the two lines. So the measurement is a guess. It's not exact. Also, any non-zero digit is significant. This will make sense later in the video. Any placeholder zero is not significant. This will also make sense more later in the video. An important rule of thumb to remember is to start on the correct side of the number. When you have a decimal point, you need to start from the left of the number and then count towards the right. If there is no decimal point, start to the right of the number and then count to the left. Remember to move in the correct direction every time, or it will change the outcome of how many significant figures you have. A good acronym to remember this is the Pacific and Atlantic Oceans. So if the decimal is present, hence Pacific, present Pacific, you start from the left and move to the right. If the decimal point is absent, hence absent Atlantic, they go together, you start from the Atlantic, which is on the right side of the United States, and you move towards the left. So present equals Pacific and absent equals Atlantic. So let's review some samples. Let's state the number of significant figures within each number. In our first value, we have 140.31. So, since we see that there is a decimal point present, we're going to start from the Pacific, which is on the left. So we start counting from the left. This is the first non-zero number. So for instance, if we had a 0 here, this would not count, because this would count as a placeholder 0. So this would not count. So we would start from the first non-zero digit from the left side, because we have a decimal point, and we start counting 1, 2, 3, 4, 5. So this value has 5 significant figures. I'll just use SF as an abbreviation. In the next problem, we also have a decimal point, so we will start from the left side. However, we see all these zeros. These are all considered placeholder zeros. So, remember from before, the slide before, any placeholder zeros are irrelevant to the number of significant figures. So we will cancel out all these zeros because they are irrelevant to us. However, then we reach the first non-zero number, which is 4. So then from then on we will start counting. So we have 1, 2, 3, 4 significant figures. So that will leave us with 4 significant figures. These zeros do matter because they come after the placeholder zeros and after the first non-zero number. And because, once again, because of the decimal point, we start from the left. Also here we have a decimal point. This 0, as we said before, is irrelevant to the number of significant figures. So we will start from the first non-zero digit and count 1, 2, 3, 4. So that will leave us with also 4 significant figures. However, in the next problem, we have no decimal points. So when the decimal point is absent, we will start on the right side, which is the Atlantic. And remember, any zeros starting from the point you start on are irrelevant to the number of significant figures, unless they come after the first non-zero digit in the direction you're moving towards. So starting from the Atlantic or the right side, these zeros are placeholders, which we will cancel out, and they are irrelevant to the number of significant figures of the overall answer. So the number of significant figures in this value here, is 1, 2. So we only have 2 significant figures in this value. Also, just a little side note here. We see that this number creates 4 significant figures. If we were to write that in scientific notation, which is a very common way to write the numbers, we would use 4.100 times 10 to the negative 4th power. So the only place we look for significant figures here is in this part of the equation. This is just to tell us how many places the decimal point moves, whether negative 4 to the left 4, or if it was positive 4 to the right 4. So as we can see here, we correlated this 4 significant figures to the correct number of significant figures in the scientific notation. So as we have a decimal point, we start from the left side, and we have 1, 2, 3, 4. 4 significant figures, which matches up with the 4 significant figures we counted from the original value. So, calculation of significant figures. We will talk first about multiplying and dividing. The next slide will show us adding and subtracting. So, in multiplying and dividing, the number of significant figures in the answer must match the starting number with the fewest significant figures. This will make more sense in the example problem that I'm about to do. So in this problem, we have 34.56 times 12.930. So as we look here, 34.56, let's start by counting the number of significant figures in this part of the problem. So as we see, we have no zeros, and we have a decimal point, so we start from the left side. Our first number is non-zero, so we will count that number. So we have 1, 2, 3, 4. So we have 4 significant figures. Now we move on to the right one. We have 1, 2, 3, 4, 5 significant figures. So we have 5 significant figures in this problem. So if we were to multiply this all out with a calculator, we would get 446 point 8608. Make that more visible. That's a point. As we see here, the number of significant figures is incorrect because this is just a calculator answer, and the calculator, remember, knows only how to calculate, not think. So we must think for ourselves and determine the number of significant figures we need inside our answer. So we need the fewest significant figures from the original problem. We see here that the fewest was 4. So we will only use 4 significant figures in this problem. So that would round up to 446.9, which is the 4 significant figures we needed taken from the original values that was given. Adding and subtracting is a bit different, however. The answer must be rounded to the same level of precision as the least precise starting value. So in a sense, the number of decimal places with the answer must match the starting number of decimal places from the least amount of the values given. So, for instance, in the sample problem, 22.143 has 3 decimal places within it. So 3 decimal places. So after the decimal, we have 3 values that come after the decimal place. In the second part, we have 4 values that come after the decimal place. So when we do our calculator answer, we get 20.3938. Now, because of the principle of significant figures, we must match the least amount of decimal places from the starting values. So whichever one has the least, that's the amount we need to use. So over here, this one has the least amount of starting decimal places, which is 3. So we have to round our answer to 3 decimal places, which would become 20.394. See, not the overall value that we need for significant, we need to match significant figures, but it's rather just the decimal places with adding and subtracting that we need to match up with significant figure values from the starting numbers.